Well, greetings, mathletes, and welcome back. We're going to be talking about the derivatives of trig functions today. Now, the derivatives of trig functions by themselves is not a terribly huge topic because once you know the derivatives of those trig functions, the six trig functions, you know the derivatives. Um, so we're going to take a little time to look at how these things play together as well. But other than that, it's pretty straightforward. Once you have the derivatives of the trig functions, it's just a matter of using them with the other derivative rules we have. And if you think about the ones we have, the main ones we want to be thinking about are the power rule, the product rule, and the quotient rule. And we'll actually, in the next lecture, have one more rule to play with, and um, that will actually end the stuff we're learning about techniques of taking derivatives, and then from there on, we're going to be using it for stuff. So, in any case, let's go ahead and get started here. Now, I'm not going to go through the entire derivation process, but the main things we want to remember here, actually, let's make that smaller. There we go. Is that if I want to take the derivative of sine, what I get is cosine, right? Okay. Now you can do this from the difference quotient, taking its limit as h goes to 0, all that stuff. You end up using an angle sum identity and massaging it around, and you end up with cosine. I'm not going to go through the whole derivation of that. That's actually something that's, well, it's in your book. You can look at it if you want. But this is one item that we need to know. And the other is that the derivative of cosine x is equal to negative sine x. Now, this fact alone is kind of interesting because what that means is if I have a function, oops, not a primed function, not a derivative function, here we go, a function that is sine of x, and I want f prime. Well, f prime is cosine of x. If I want f double prime, right, the second derivative, it's negative sine. So negative sine is the second derivative of sine. Now, if I go ahead and take the third derivative, right, and take one more derivative, the derivative of negative sine would be negative cosine. And you notice it's kind of repeating itself. If I go to the fourth derivative, I end up back where I started with because the derivative of sine is negative cosine, and the derivative of cosine is negative sine, and so this would make this the negative of negative sine, which is positive sine again. So the derivatives under sine and actually under cosine as well follow a cycle where they come back to where they started, right? And they do it each time. So they do have kind of an interesting thing. It really, and actually it is kind of related. But remember the imaginary number, if you take powers of that, you start to repeat itself too, right? If I have I to the 0, I get 1. I to the first, I get I squared, oops, is negative 1. I to the third is negative I, and I to the fourth brings you back around to 1. I to the fifth would be I again, right? And so there is actually a connection between these. We're not going to be using that connection, but it's something to think about. It's a good thing to wonder about. Like, what is the connection between those things? Now, so we have the derivative of sine and cosine. That is actually sufficient with the tools that we already have to find the derivatives of every other trig function. So let's go ahead and take a look at tangent first. So let's say I want to find, let's say I want to find the derivative of tangent x, right? Well, I know that tangent x is sine over cosine. And so what that means is that the quotient rule is in play, right? And so if I use the quotient rule, this is low cosine x d high. I'm just going to write this d dx of sine x minus high sine x d low d dx of cosine x Let's see if I can put a little x there. There. Over the square of what's below. And the square of what's below would be cosine squared x. And so I'm just using the quotient rule here. Now to take these derivatives. Well, the derivative of sine x is cosine x, so this makes this cosine squared x. And the derivative of cosine is negative sine, which makes this plus sine squared x over cosine squared x. And notice that this numerator is the Pythagorean identity. So this is 1 over cosine squared. And 1 over cosine squared is secant squared. Right? And so the derivative of tangent is secant squared. Right? That's kind of cool. Now, the other two follow from a very similar thing. All you do is you take secant and write it as 1 over cosine. You take cosecant and write it as 1 over sine, and you use the quotient rule again. And what you end up with for the other two derivatives, let's see, d dx of secant x is secant tangent. And the derivative of cosecant x, oh, actually I have to finish writing the derivative part of this. I can't write today, it's fine. Cosecant x, there we go, is negative cosecant cotangent. And the derivative of cotangent is negative cosecant squared x. Okay, so these are the rules we're really dealing with, right? And any of these can actually be found from the first two. I remember when I took calculus, I actually didn't bother memorizing any of these guys over here. I worked everything out from sine and cosine. Just for me, it made more sense. It was less for me to memorize, but it was more work as far as the algebra part of things go. Okay, so we have those derivatives, and that's what we're going to be dealing with. That's what we're going to be calling on as we go through some of these examples here. Now that we have these, pretty much everything else is just how do we use these with the other rules that we already have, right? So let's take a look at some. Okay, so our first example here, so our function, excuse me, actually let me adjust this just a little bit. There we go. So the function we're going to be dealing with here is f of x is equal to, where did I write it? There it is. 3 over x plus 2 sine x. All right. So looking at something like this, let's see what we got here. So I know I can take the derivative one term at a time. I think it's going to help me if I'm looking for f prime. Right, I'm looking for f prime of x, to take each of these derivatives using the power rule. So I want to, actually it's not a prime yet. Actually, I'm just going to get that off there so I don't mislabel this. So I'm going to rewrite the function as 3x to the negative 1 plus 2 sine x. Now if I do that, and I bring this to the front using the power rule, that gives me negative 3x to the negative 2. And then taking the derivative over here, I know I can pull a constant through the derivative. So all I have to do is take the derivative of this function, which is cosine, right? The derivative of sine is cosine. So this is 2 cosine x. Now, something about negative exponents. There's actually nothing inherently wrong with leaving your answer as a negative exponent. There is kind of a tradition, and it's nothing more than a tradition. It's a convention, the way people do things. Quite often, whatever the form, you notice the original form of the function did not use negative exponents. So your final answer probably shouldn't. Just that's the convention. Whatever the form was used in the original problem, you should probably use that with your answer as well. So since this is f prime of x, but I'm going to rewrite this. So f prime of x is equal to negative, actually, let's put that up higher. Negative 3 over x squared plus 2 cosine x, right? That's it. That's the whole thing. So basically what we did was, because we know what these things are, we know these derivatives over here on the side, we can actually just jump to answers instead of having to do a bunch of computation, right? Okay, so let's look at another one and see what else we got here. So let's, no, I can't do that. Do it this way. Okay, so let's go ahead and delete that. And okay, let's say our function then is cosine x over x, right? And we want to look at that. Well, there's actually a nice way to think about it. Well, there's two ways to look at it. You could either look at it as x to the negative 1 times cosine x, or you can look at it the way it is and use the quotient rule. So we could use the product rule, but I'm going to use the quotient rule on this one just so we get some exercise using it. Okay, so if I'm going to compute f prime, it's going to be low d high, the derivative of cosine is negative sine, minus high d low, the derivative of x is 1, over the square of what's below, which is x squared. So if I go ahead and rewrite this, I have negative x sine x minus cosine x over x squared. And there's absolutely nothing wrong with that, although it may be, since both of these terms are negative, sometimes it's a little easier. Sometimes people want to write this instead. Oops, plus cosine x over x squared and just throw a negative out in front, right? So that happens as well. So both of these are the same answer, basically. Both of these are the same answer, basically. They are both correct. And I don't think that my math lab would actually distinguish between those two answers. But this one may be the more likely one to see as in an answer key or something like that. Okay, so let's go ahead and take a look at another one here. Let's see what we can get going. So let's do that and go ahead and delete that. Okay, so this is one I want to see if you guys can do this. This is a good way to test yourself. And you really don't know if you know something until you can do it on your own. So let's do sine x tangent x. Okay, and we're looking for f prime of that. So go ahead and pause the video here, see what you can work out, and then I'll go ahead and work it out, and we'll see if you match. Okay, so pause it here. So I'm assuming you've paused it now. So let's see here. So we have a product of a sine and a tangent, right? And so that means I can use the product rule. So the product rule is the first times the derivative of the second plus the second times the derivative of the first. Or 1d2 plus 2d1. So let's see here. So I got this would be 1 and this would be 2. So 1 d2. I'm going to run out of room. I'll just do it here. Plus 2 d1. Okay, so we just need to simplify these things and figure out what we got. Okay, so the first one, I need the derivative of tangent. So let's see here. Oh, that's secant squared. So I have sine x times secant squared x plus, oh, we got tangent x, and the derivative of sine is cosine. Okay, now this is a perfectly good answer, but it may be able to be simplified. So let's look at this. So secant is 1 over cosine. Let's see if that does anything for us. Let's see. Well, let's just look. Now, keep in mind, this is a correct answer. Okay, sometimes you just want to massage it and see what you can get. So let's see here. We got sine x, and secant is 1 over cosine. So this is times 1 over cosine squared plus, let's see here, tangent is sine over cosine times cosine. Oh, those can cancel. That's good. Yeah, so sine secant might be the way to write it. I think we could also, I could look at this. I could rewrite this as sine x over cosine x times 1 over cosine x. So this is now tangent x secant x plus sine x. That would probably, because I don't have any squares or anything like that, that would probably be the preferred form. But again, without any context, you don't really know which form is going to be the best form here. So it could very easily sine over cosine squared might have been the nicer way to do things. Over here, the cosines, you're going to cancel out the cosine one way or another to simplify that term. But this is a correct way to write it. This is a correct way to write it. Had I written it sine over cosine squared and then throw the sine at the end, that's another correct way to write it. So there's a lot of correct ways to write these things. I do want to say this. This is the point, especially now in your homework, where you may have a correct answer and it gets marked wrong because it doesn't match what the program is expecting. So if you have any issues like that, or if you're wondering, absolutely ask me. Let me know. There's an Ask My Professor button that you can use in the help. So, use that if you really have some issues. All right. So let's take a look at the next example here. So let me go ahead and clear this guy off. Okay, now let's take a look at this one. This is another one I think it's a good idea for you to attempt it. Depending on how things go, some unexpected things could happen here. So let's look at secant x minus tangent x times secant x plus tangent x. Okay, now I'll give you a hint before you pause this here. There's things you can do to make this look a lot easier. Okay, so pause it here and see what you can do. Okay, I'm assuming you've paused it. Now, I don't know if you spotted this or not, but if I multiply these two quantities together, what I end up with is secant squared x minus tangent squared x, right? And that's equal to 1, right? That's one of the Pythagorean identities. Secant squared x minus tangent squared x is equal to 1. Well, that means that f of x is 1, which means that f prime of x is 0, and that's it. So if you massage it a little bit, you get it to break down into something really, really nice. And I noticed there are some problems like this in the homework. So you do want to keep an eye out for things as far as that goes. This one was deceptively quick. It would take some time if you were doing, using the product rule along with everything else to take these derivatives one at a time. It'd be quite a mess. But if you spot the right thing, everything collapses. So it's beautiful. All right, so let's look at the next one here. All right, yeah, I think I'm going to get rid of this too. Let's just go ahead and clear all of that off for the moment. Okay, I'm assuming you've written those down. That's one of those things that you're just going to have to memorize. So this next one, so I got the pen on, good. It's kind of an interesting problem. Cubed. It's a little bit different than what we've seen before as far as taking derivatives because of the fact that it's the product rule used twice, right? So I have a product of the x cubed is being multiplied by sine, which is being multiplied by cosine. So when you're using the product rule and you have three pieces in the product, you end up using the product rule twice, is what ends up happening. So it just depends on how you break it up. You could break it up so that x cubed sine x is your first function and cosine is your second function, or you could break it up so that x cubed is your first function and the product of those two is your second function, right? That's our first level of computation. And I'm going to break it up the way I have it written right now, with x cubed first and then sine x cosine x, just so you can see the whole process, because it does get kind of complicated to do in your head, so you have to break it down into smaller pieces. So x cubed will be my 1 function, and this product will be my 2 function. And so I know f prime of x is going to be the first times the derivative of the second, and I'm not even going to try to take this derivative yet. Right? Plus the second, which would be sine x cosine x, times the derivative of the first. Okay, now what we're going to need here is the derivative of sine x times cosine x. So what I'm going to do is I'm going to just step out for a second, and I'm just going to look at d dx of sine x cosine x, right? This is just a side computation. This is scratch work. I'm just doing it in a different area so it doesn't interfere with what I have written. So again, that's a product rule. So this is the second use of the product rule. It's to proceed from step 1, or proceed from step 2 to, well, is this step 1 or step 2? I don't know. To proceed from this step to the next. We'll say it that way. Okay, so again, it's 1. Actually, I'm going to write it underneath so we have room for all of it. So it's 1 d2 plus 2 d1. Yeah, let's see, the derivative of sine is cosine. So what that ends up being is negative sine squared x plus cosine squared x. Now, there are some identities for this. The cosine squared x minus sine squared x. We may or may not need them. I'm just going to leave it in this form for the moment because I know that's what this piece right here is equal to this. So I'm just going to write it in. So that means I have x cubed times cosine squared x minus sine squared x. Let's see here, plus sine x cosine x, and that's going to be times the derivative of this, which is 3x squared. Okay, so just to clean it up a little bit here, I can move the 3x squared out to here, so this would be x cubed times cosine squared x minus sine squared x, and that'd be plus 3x squared sine x cosine x. Now, that's just putting things in a more familiar form because you usually don't leave these guys hanging off on the end here. But this is a completely correct answer, right? There's nothing wrong with that. The only thing that might happen from here is that there might be a couple of substitutions because this quantity here, I gave you guys a sheet before, and if you look at this sheet under the double angle identities, I could rewrite this as cosine 2x, right? I could also rewrite this as let's see, what else do we have? 2 cosine, 2 cosine squared x minus 1. And it's just making substitutions using the identities. There's another identity in there too. It's 1 minus 2 sine squared x. And so depending on what you need, you may want to substitute some of those others. But my advice, once you get it to a form like this, unless there's a reason you need to have this all housed in terms of cosine or something, or all in terms of sine, there's no reason to do any extra steps, right? But just be aware that sometimes you do need to make it fit something else later on down the line. So, okay. And so the big thing I want you to take from this is that once you have the derivatives of sine and cosine, right, you have the derivatives of all 6 of the trig functions. It's probably best to memorize all of them, right? You could get around it by just memorizing sine and cosine. There's no way that you're going to advance through calculus if you don't know the derivatives of sine and cosine. That's just expected knowledge. Other than that, it's just using the rules we had before, the power rule, the product rule, the quotient rule, the constant rule, the rule about sums, all of that stuff that we learned in the last lecture. We're just applying that to a new derivative. And in the next one, we're going to learn one more technique, and that's called the chain rule. And the chain rule gives us access to a lot of stuff. It actually opens up a whole different thing of how to take derivatives once you have the chain rule under your belt. So that's where we're headed from here. And so until next time, keep your pencils and your wits sharp.